Hi, we're in the workshop today and a friend of mine dropped this generator off and he asked would I like to have a look at it. Now the engine itself's running okay, so that's not the problem, but what the problem is there's no voltage coming out of the outlets here. So what I'm going to do, I'm going to put some gloves on. We'll take this part apart and we'll see if we can diagnose the problem and hopefully repair it. Right, I'll go and get some gloves on. Right, back with some gloves. And also, what I've done, I've made a little extension lead here because I haven't got anything that I can really plug into this generator, but I've got plenty of things on a normal UK 3-pin plug socket here. So I think what we need to do first is to just plug something into it, fire it up and see if we are getting any voltage, because it could be a problem with these lights or something else. Because I think the farmer uses it for powering these lights in a barn that hasn't got any electricity. So, right, we'll plug this in, we'll plug a light into it and then we'll fire it up. And I'll just go and grab a light. Back with an LED strip light here. So I'll just plug that in. We just better check these breakers around the other side, I think. Because I've noticed there is a couple of breakers. So the breakers are just down here. Let's just check that they aren't tripped. And let's just check that it's set to 230 volts. That's 115, which is the yellow socket. And we're plugged into the blue socket here, which is the 230 volt one. So we'll just make sure that that's set. Right, let's start it up and see what happens. We'll just switch the engine on. Well, that's it running, but the light's not lighting up. So I think what we'll do is we'll check and see if we've got any voltage at this plug. Well, we do have something, but we've only got about 16 volts there, but that's not right. So there's obviously something broken in here. So it looks like we need to get into this part of it, I would think. Now, I've only ever really worked on a generator one at that time, and that was the one that was quite a bit larger than this. I'll just bring up the thumbnail so you can have a look. And the only other thing that I've had to do with generators was a control panel that somebody didn't have a pin number for, which I managed to sort out. And that was another video. I'll just bring the thumbnail up so you can have a look at that one. And I had to disassemble the EEPROM and figure out how the pin code was stored, and we managed to sort that one as well. So let's see if we can sort this one. Right. So it's attached at the back here. There's a couple of screws. Let's take this earth wire off. And there's not a lot in there. There's literally just a few wires and a plug that disappears into here. I think what we'll do first, we'll check the continuity just in case one of these breakers has failed or something. But then again, I don't think it would be that, because we're getting some voltage out. Well, I suppose it could be a resistance, a high resistance on one of these breakers and not letting the voltage through. I had something like that with a fuse on a Milwaukee vacuum, which let some voltage through. Right, let's just get a better view of this. Right, let's just go into resistance. And let's see if I've got, I'll tell you what, I'll plug this back in. That'll be easier. And we'll see if I've got resistance from this collector here to the one that goes to the coils. Or continuity. So yeah, we'll go into continuity. It's a bit hard to get everything in shot. Right, so we've got continuity from that pin there to this pin on the plug. Let's just try the other one. Yeah, so it looks like it's those two spade connectors there that give the power output. Let's see if we can match that up with the output on here. So that would be these two here. So let's see if we've got resistance across those two. Just in case one of the windings has gone open circuit or something. So I'll just go into ohms. Interesting. I've got an open circuit there. Why is that? Do we get into continuity between any of the other ones? Right, so we've got 1 ohm between the brown and the black one. Let's just check the blue one. Let's see if we get continuity to here. And we've got 1 ohm between those two contacts as well. So I guess when you flick the switch between 110 and 240 volt operation, just here, what it must do, it must link those two across. So perhaps there's two 110 volt outputs and it just links them in series to give the 230. And when you flick the switch the other way, it just either links them in parallel or just uses one of them. That's what I kind of think anyway. I wonder if I can get this cover off. Because I remember on the other generator that I looked at, that wasn't giving out the correct amount of power. That was something called the AVR that wasn't working on it, which is the automatic voltage regulation as far as I know. Yeah, let's have a look in here then. Let's see if I can get this panel off. I'm not sure how this comes off. Oh, there we go. Well, that doesn't reveal an awful lot. I'll just move down a bit so you can get a better view. And I can just see some coils in there, can't really see anything else. I can see a diode down there. I'm not sure if you can see that on the camera. See if I can spin that around to the top. Yeah, so I've got a diode there. But I can't see any regulator or anything, or any AVR, so I'm not sure how this regulates its voltage. I mean, you know, the other thing I'd think is, are these windings burnt out or something? Unless it's got some electronics further back in the front there, because I don't know whether there's some brushes or something that control this centre bit here. I think it's the armature. Because I know on some generators I've seen there's like a couple of brushes and it varies the intensity of this coil to regulate the voltage. So I'm just wondering if it's something like that. I think we might have to pull this part off to have a look. Right, I'm going to get some spanners and we'll see if we can get this part off. Right, so I'm going to see if I can remove this whole part from the engine, just so it's easier to have a look at. So I'm going to try and remove these bits of plastic, I think, first. I'm sure if they just click off somehow, like that. Should be a big nut under here, I think. Right, now I'm not sure whether this bit will just come off or not. I'm just going to get something to try and tap this with. I'm not too sure how this bit comes apart. Right, unplug this. Let's try and doing these ones. Don't forget to undo that nut as well. Right, so I need to try and lock that up from turning. Let's just see if I can wedge a screwdriver just in the side there. That's a long bolt. Let's see if that gives her any access into anything. Something moved. That doesn't really help. Let's see if we can get this front part off. Let's see if I can get a screwdriver in there. Tell you what, let's put something in there because I don't want to damage these coils. Let's see if I can get a screwdriver in this gap. That seems to be doing something. Let's try the other side. Right. Right, we've got this part off. Right, let's have a look at this side, see what we can see. Well, there's not a lot on here. I can't see any voltage regulation or anything. It just looks like I've got a little high voltage capacitor there and a diode. I can't see anything else in there. There's just a fan at the front. Let's just check what the resistance of this coil is, just in case that's gone open circuit or something. It's a bit hard to hold the meter in place as well. We've got about 2.8 ohms there. But it's going to be hard to check that diode because effectively we've got a short circuit, well, nigh on a short circuit across it of the coil windings. So the only way would be to check that diode is to remove it. Right, let's have a look at this other part. Right, have we got any electronics or anything in here? I can't see anything, it just looks like just coils. I mean, the coils don't look too bad. I can't see any burn marks or anything on them. That side looks okay. So I'm unsure how this regulates the power, because there's no electronic board or anything. So why is it not outputting the voltage? Let's just check across these two yellow wires because we didn't check those. Let's just see what reading we'll get on those. Let's try and get the meter in shot so you can see it. So we'll get about 7 ohms on those. So we're getting resistance on all of the coils. The only other thing we've got here is this capacitor. So what's that? 13 microfarads at 420 volts. Now this meter that I'm using, it's one of my older meters, it doesn't actually do capacitance. So I'll go back over the house and I'll grab my Peak ESR 70 Gold and we'll use that to test this capacitor, I think. Right, back in a moment. Right, back with the ESR 70 Gold. And we'll just check that we've got no power in this capacitor first with my safe capacitor discharge tool here, also known as a screwdriver. Actually, somebody sent me a rather nice capacitor discharge tool, but I haven't used it yet, so I'll be sure to mention him and his site when I use it on a video. Right, let's see what this measures then. Well, that's not 13 microfarads. I don't know if you can see that there. It's a bit hard to get on the camera with the light level, but it's saying actually not saying 0.52 microfarads and 1.94 ohms on the ESR. Let's just try that again. Yeah, 0.52 microfarads. So that capacitor seems faulty. I wonder if that's the problem with it. Right, I think what I'll do then, I'll put this back together. I'll see if I can find a capacitor and then we'll try it. I want to see if it's pulling all that apart, if I'd have known that. Never mind, I suppose it's just the way it goes sometimes. I suppose that now at least I know what's in one of these. So while I'm assembling this, let's talk about how it actually works. Because I was a little bit unsure, so I had to do a little bit of research. But because I was unsure how it actually started off, because there's no magnets inside of it anywhere. And I was thinking, well, how does that work? So what happens is, we've got this rotor here with a coil and a diode across it. And we've got the stator here, which has got the two coils which go to the load. So one will be, I think they're both 110 volt, and it just links them both together here to get the 230. And we've got this other winding here, which has got the capacitor across it. So what it relies on is, because this has been magnetised previously, it's got a little bit of residual magnetism left in it. So as this turns, it induces some voltage and current in this coil here, which then charges up this capacitor. This capacitor then discharges back through this coil and induces more current in this coil here. And because we've got the diode here, it means that this pole here would always be north and this would always be south. Because if we didn't have the diode there, these would be obviously flipping depending on what orientation it was. So as this rotates, it then adds more current into this inductor here, charges the capacitor, and the process repeats until this rotor is fully magnetically saturated. And at which point the generator output stabilizes, and that's how it sort of regulates the voltage as well. So it's fairly simple once you actually understand it, but the bit I didn't understand was, where does the initial magnetism come from? But it's residual magnetism that's in this core. And what happens is, sometimes they can lose this magnetism and then the generator won't work, and you've got to remagnetise this slightly to actually get the generator to work again. But in this case it was this capacitor, so it wasn't energising this rotor fully. The magnetism wasn't building up to its full capacity, and that's why we weren't getting the voltage on the outputs here. So I hope that's a simple explanation and clarifies how it works. Right, I'll see if I've got another capacitor then. Well, this one's a 13 microfarad, but what I've got is a 12.5 microfarad, and I bought this for, I think it was a bouncy castle motor, and I think I bought two at the time, just one as a spare. So I don't think half a microfarad will make a lot of difference, especially how this one was reading practically zero. So we'll give this one a go. So I think it's maybe slightly bigger than this one. Yeah, it's slightly fatter as well. So I'll have to cut this cable tie off, and I'll see if I've got another cable tie, and we'll see if we can attach this one. Right, so I'll go and find some cable ties. I'm back with some cable ties, or a cable tie. Set this one off. Right, I'll get this back on there. Right, we'll put the cover back on. So all the covers back on, and I've refitted the little plastic covers that went round the housing there. Let's plug this mains adapter back in. And let's fire it up and see if we get any voltage now. Well, that looks promising. Let's just try plugging this light in. Excellent. So I think that's it. Right, I'll just switch this off. So that looks like what it was then. A faulty capacitor. Well, you know what, a lot of the comments say it's always a capacitor. Well, right on this occasion. Let's just double check what that measured. 0.52 microfarads. So definitely goosed. Oh well, one fixed generator then. Excellent. So we'll call this one a fix then. Right, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.